And so with that, we will start talking about decision making in Java. So the objectives here for this chapter, read the chapter in the book on decision making, and there's a number of new keywords that we'll introduce, we'll go over. A lot of this is going to feel like repetition if you remember all of the stuff that you learned about Python, except that at least if you had me for Python, you probably remember me pointing out to you here and there, hey, I'm going to teach you all these different patterns, but this particular one, there's no way to do that in Python. But there are ways to do that in other languages, so we're still going to talk about it. So that way it's not maybe brand new the first time you've ever conceived of the idea when you get to C++ class or C# class or Java class. And so hopefully some of this stuff rings a bell when we start pointing it out. But there's a bunch of operators that are specific to if statements and conditional logic. There's Boolean expressions we'll go over. We get this new multiple condition operator. And then I wanted to talk a little bit at the end, if I don't forget, to just go over a little bit about desk checking and tracing, and then a little bit about unit testing. These are very important things to know how to do. They will make your programming assignments that you turn in more robust, higher quality. You'll get dinged on fewer occurrences of bugs. Well, the teacher never told me that they were going to enter that as input, so how was I supposed to know, right? Well, we need to think about those kind of things. So if you remember back to our many discussions of structured programming, we have these three main control structures: sequence, selection, and repetition. So selection is the one that we're going to be talking about today that involves decision making, and that's the selection control structure. You remember we kind of talk about these things, and the idea is that there's only three of these control structures, and you can mix and match them, plug them in, put them inside one another in various ways, and there's some distinguishing features of these things. One of them I want to point out is that there's always a single point of entry and a single point of exit. The sequence one's kind of boring because it basically is the rectangle symbol on your flowchart. You're going to do something, you're going to take some action. Or the little parallelogram ones where you're going to do some input or produce some output. And sequence just means we're going to execute them in the order that they appear from top to bottom. But if you take a group of those boxes that are all strung together top to bottom, there's an entry point into the first one at the top, and there's an exit point out of the bottom, out of the last one at the bottom. Okay, so one point of entry, one point of exit, even though there's one too many of these boxes strung together. With selection, I want to make that point because when we start seeing some of these patterns later, people take shortcuts when they do the flow charts with if statements often, and it gets them into trouble. And you kind of have to remember, wait, for me to do this correctly, where's my single point of entry and my single point of exit? So just kind of file that away in the back, and hopefully that'll help you. And then same with repetition when we get there next week. So we want to talk about what these look like in a flow chart. I like that. I probably won't be having you do a lot of flow charting in here, but to me, if you understand how to flow chart it, it helps you create a visual plan for it. Some people, like to just jump in the editor and start ripping. Other people like to see it as a picture. It's like some people, when you give them directions to the store, just tell me, go down here, take a left, go down there, take a right, and there you're. Other people, it helps if you just draw them a visual map of how to get there. Just different people think different ways. And the point is here, we're going to use these things to solve various problems, so you might imagine that you're going to get a programming assignment at some point that uses these, like usual. So just a summary of the different patterns that we're going to go over here. They'll take one of these forms. First of all, I like to point out that stuff would have been going on previously in your program, right? You're going to have, maybe you print some headings, maybe you ask for some input, whatever. You're going to do some stuff ahead of time. Then you're going to have one or more of these selection control structures. And then down at the bottom afterward, your program can very well continue on executing additional code. That's a perfectly acceptable expectation for an algorithm. So the first one we'll talk about is a simple one, and that's, it's pretty easy. Then there's the standard one, which is, it uses all of the normal features of a condition: compound, nested, switch, and then there's a few other weird variations, edge case type things that we'll talk about, because Java has them and they're actually kind of convenient when you know that they're there and know how they work. But that's the summary, and we'll get at each one of them now. So before we just jump right in to the deep end there, I want to review what the selection-oriented operators are in Java, and remind you of the term expression. Expression is something that the virtual machine, Java virtual machine, will resolve to a value. If you put a string in double quotes, that's an expression that resolves to that string of characters. Well, with these selection operators, you'll also hear them called conditional operators, comparison operators, and you've seen these before, except that in some languages they're expressed differently, and that's the reason why I kind of pedantically point out the list of what they are. For example, the not equal to, in some languages it's less than greater than is not equal to. Yeah. So hopefully no surprises there. The double equals, in every language that uses double equals for this comparison operator, they call it equal to. I like to throw the is equal to in there when I read that. So if I see this example on the right, x equals y, the way I read that out loud is x is equal to y. And that just reminds me that it's the double equals, not the single equals. Because if I say x equals y, I'm assigning y to x. It's a different operator, and you read it differently. It means something different. But very common problem that programmers will mean if x is equal to y, but they'll only use one equal sign, and that does something completely different. Some languages are nice and they warn you that you just did that just to make sure, hey, did you mean to do that? And I'll put a warning on that line when you compile it, but some languages don't. Okay, so here's the first one. I got a little code snippet there. I'm also showing you an example of how to create a random number in Java if you've never done that. Going back to our object-oriented discussion last week, this first statement here, it creates a new instance of a random object, an object called random, right? So I create a new object of type or class random, and now I have a reference to it in this random generator variable. So to use that object, I will invoke one of its methods, which is next integer. And it has an argument, 10, which says, give me the next random integer between, okay, so now you got to read the documentation. Is it going to give me a random number from 0 to 9? Or from 0 to 10? Or 1 to 10? I don't know. And I don't try to remember that. Most of the time when I use one of these objects, I'll just Google it to make sure, because different languages have different sets of standard objects and they work differently. Like VB, it wouldn't be unusual for Visual Basic to have a function like that that returns a random number from 1 to 10. But I would guess, what I know about Java, I'm guessing that all the numbers that you get from that are going to be from 0 to 9. I would guess that you will never get the value 10 back from that. You can get one of 10 different values, and they will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Pseudo-randomly, okay? But it's a new object. We're learning about it. Google it and find out what the arguments mean and what range of values you could get back. Or you can play around with it and test it and see what it does. But the random generator, it's kind of hard because how many times do you have to call it before you're sure that it would never return the value 10? 100 times, is that safe? 1,000 times? 10,000 times? So maybe just read the documentation. But my code here then says, okay, I got this value back that's a random number between, let's say, 0 and 9. And I'm going to say, is it greater than 5? Then do this print statement. So here's our example that I'm here to talk about, which is if the condition value greater than 5, that expression, if it's greater than 5, that will resolve to the value true. And so I'm basically saying if this is true, then do this print statement. That's our simplest form of the if statement in Java. And I will try not to belabor the point because, like I said, you've probably seen this before. You know what an if statement is. This is just how it looks in Java. And on the right, you can see that's how you flowchart it. And you're probably able to guess what point I'm going to make here. We're doing structured programming. This is a selection control structure. We have one point of entry at the top and one point of exit at the bottom. And the shortcut that people sometimes take is like this no path will go off somewhere else. It's like, no, you need to come back down here and connect up because the two things, they need to join back up and continue to one single point of exit. Everybody get that? Okay, so that's the easy one. This one isn't too bad either. It, just basically also does something when it's not true. So if value is greater than 5 is true, then I do this, else I do this. And one of the other things that I'm going to point out here is I find it interesting that nobody observed, why am I comparing value greater than 5? Does that raise any eyebrows? Any thoughts, concerns? You just assume that everything that I do is correct all the time, right? Well, think about it. What I probably was trying to do here is I wanted to print this half the time and not print it the other half of the time. But what problem do I have with that code, the way that's written?
Like if the value is not greater than 5, then it's going to result in some blank or an error.
That is true.
Maybe it's missing an else statement.
And because it might be going from 0 to 9
Yes.
instead of 1 to 10.
Yes. So what does that have to do with it?
5 isn't in the middle.
5 isn't in the middle. Okay, so again, very common issue, logical issue, a logical error, if that was my intention. Maybe that wasn't. Maybe this is exactly what I intended. But yeah, you got to have in the back of your mind to watch out for these little things. I should have probably said if value is greater than 4, because then 5, 6, 7, 8, 9 would have gone one path, 0, 1, 2, 3, 4 would have gone the other path. It's not half and half the way I coded it. Another way I could have fixed it is with my operator. Instead of greater than 5, I could have said greater than equal to 5. Right? You guys get where I'm coming from here? You got to start thinking in those terms. What operator am I using? What am I including and what am I excluding in this expression? Because the computer will do exactly what you ask it to, and sometimes not what you meant for it to do. Okay, same thing with this one, but I've already made that point, so I will just go on, assuming that you understand that. But notice my else side of my if here, I said if value is less than or equal to 5. So that's correct. It just may not be what I intended for it to do. Okay, but yeah, another thing I want to point out here is, notice where I put the curly braces. This is just a programming style thing. One of the religious battles that I've seen happen at different companies over the years is where to put the curly braces and how much to indent. You wouldn't believe the religious battles that happen. And teams can split and say, well, we're going to do it this way. You know, it's almost like a church splitting over some, point that somebody wants to make, who's going to lead the music or whatever. But here, I put the curly brace on the same line as the if. Very common programming style for Java. But in this one, I showed you a different style, which is dropping the curly brace down. Now, it's a point of preference, whether you like it one way or the other. But my expectation is that you'll pick a style and you'll stick with it. And that you also don't become religious about it, because if you get interviews and you're going to go to company A versus company B, one may have one standard style that they insist the developers use. The other may have the opposite and may be just as dedicated in their reasoning for why you have to do it that way and every other way is wrong, right? So just be personally flexible, but then consistent in whatever the accepted programming style is, okay? If that makes sense. That way you can work anywhere, you can work with anybody, but to do it correctly, you just want to be consistent everywhere you do it. So I haven't been consistent here. Here I'm using one programming style, and here I'm using a different programming style. Has nothing to do with the Java code that gets generated or the efficiency or anything. It just maybe uses an extra line of code on the screen. You can say, oh, this line is more compact, or this style is more compact and I don't use so many lines of text, which works really good for PowerPoints. Because I always want to cram a whole bunch of stuff in there and make the font as large as possible for you guys to read it. So this is very advantageous when that's your goal. But this can be a little bit more readable because there's a little bit more natural white space in there. Okay? If you've done Python, you probably remember indentation is very important in Python. It means stuff in Python. Well, here it doesn't mean anything. You can put everything on one line as long as your curly braces match up. But for us humans that want to read this, I always thought it'd be a good idea for them to create the IDEs, the text editors that we use for programming, where when you hit File Save, it saves it with absolutely no white space in the file. And then when you open it up, it looks at your settings for how you would like to read your source code, and it formats it accordingly. That would be really cool, but I haven't seen any editors do that. Because then it would have gotten rid of the religious arguments. Two developers working in the same company on the same team, and they both see the code the way they want to see it. So if you go to work for Microsoft or one of these companies that makes editors, JetBrains, throw that idea out there and maybe we'll get a better class of editors at some point. But, okay, all of that stuff aside, you get the point here. We're going to go one path and do one set of operations if it's true and another set of operations if it's false. And then once again, we join up and connect at the bottom and have one single point of exit, which would be down here where this bottom curly brace is, where the logic comes back together again. Okay? Now another little brief aside. When we talked about the comparison operators, greater than or equal and all that, But there's also these logical operators. And what these do is they combine two sub-expressions, clauses, if you will, with a logical operator to make a new super expression. Okay, so once again, we've got this pattern of two ampersands, like we had the two equal signs, which begs the question, is one ampersand a legal operator in Java? And might it do something very different from the two ampersands operator? And you'd be right there. The single ampersand, the single vertical bar is bitwise operators. And we're not going to go into those today, but you can Google them or look on W3 Schools and see what the bitwise operators are in Java and what they do. But we're talking about selection today. So you've got basically and, or, and not. Is there an exclusive or operator in Java? Somebody Google that real quick, because I don't have it on my slide. See, I need a bowl of candy up here so that the first person that finds the answer, I can throw a piece of Snickers at them or something. It's getting close to Halloween, so that would be good.
So what was the question again?
It's the carrot.
Is it carrot, or just one
I think
carrot?
it's one
One carrot? Is that the bitwise exclusive or?
I'm not sure if it's.
What was the question again?
It's not, it's an exclusive or.
Okay, logical exclusive or. Is there a logical exclusive or operator in Java?
Logical order? Logical operator?
Logical exclusive or. Okay, well, we'll assume that there's not, because
Okay.
my list here on the slide, which has to be correct, just like the interwebs. You know, if you saw it on the interwebs, it must be correct, right?
There's a
Yeah,
parent.
it says it's a bitwise operator, single carrot.
Okay.
Then the
I
parent-
suspect that's the truth here. But again, you know, you think about little patterns like this and you notice them and you think, well, wait a minute. Where's the exclusive or? It's not here. Maybe there isn't one. Okay. All right, and then the point down here too bears mentioning. I guarantee about 3/4 of you won't be paying attention when I say this, and at some point you will do this bug in your code. This little line down here at the bottom, if I want to, let's say I have this exclamation point, which means not, x is less than 5. If I want to flip that around and get rid of the exclamation point, you might think, well, not x is less than 5 is x is greater than 5. But no, you got to worry about that. What if it's equal? Greater than is one way, less than is the other way, but we've got that middle part where what if it's equal? So anytime you're flipping it around, getting rid of or adding the logical not operator, you have to remember to add or remove, vice versa, the equal sign. Does that make sense to everybody? Okay, I'm going to specifically go to the quiz for this chapter, and I'm going to add a question to see if everybody's paying attention to that. Okay. Okay, another little concept when we're throwing out stuff about selection is this word called coercion. So I'm trying to coerce you into learning about the, no, that's not what we're talking about. So we have a number of different ways to turn something, a variable or a value of one data type, and result in it being treated as or changing to another data type. Okay, implicit conversion means we're just doing it, we're not making it a big deal about it, it just happens. If I have a short variable, and it contains the value 12, and I have another long variable, x, and I say x equals my short value, I don't have to do anything special. It just says, okay, well, I know how to widen that value because there's no way I can lose any data. I'm going from something that has 2 bytes to something that has 4 bytes, plenty of room for it, so I'm just going to copy the value over there. That's a widening operation, and Java can handle that implicitly, meaning without you telling it how to do it. It just does it implicitly. In other cases, there's explicit conversions. Like if I'm doing a narrowing operation, if I'm going from a long data type down to a short, well, I've only got half the bytes, so I'm going to lose quite a bit of data resolution there. So if you're going to do that, if you don't want Java to give you an error or complain to you with a warning or something, you have to be explicit about it. You have to typecast it as the data type that you want it to be converted to. And that tells Java, okay, you're comfortable with this. The logic of your program is okay with the chance that you might lose data through this operation. It says, yeah, okay, you told me explicitly you wanted me to do this, we're good. It'll just do it again. And then there's another kind of conversion, which we call coercion. I know a lot of weird words out here. Coercion, conversion. But basically, there are cases where there isn't a clean way to assume that everybody wants to do it. It's kind of like well, is there an assumed way to return random numbers? No, we have to figure out how this particular function implemented that and what it returns and what it doesn't. Similar here, like for example, if I have a string that has the word dog in it, D-O-G in a string, if I try to interpret that as a Boolean value, is the word dog true or false? Because it can only be one or the other if I try to convert it to a Boolean. And we've got several different ways that we might interpret the word dog to be true or interpret it to be false. And we have to come up with those rules because there isn't a universally agreed on across the landscape of software developers to explain to us how that works. It's not like an implicit conversion, and it's not even like an explicit opportunity to convert something. It's coercion. We're coercing that value to make it go into the destination data type that we want. And there's several ways that I've seen it done. Some languages, I think that that Python was like this. If it's a null string, or if it's null, it actually contains the value nothing in Python. Or if it's an empty string, has no characters, it's just double quote, length 0, then that's false. Anything else is true. So the word dog in that sense would evaluate to be true. So if I said if dog, then it would be true, and it would execute whatever's in the if clause, as opposed to what's in the else clause. And that's why, obviously, we're talking about it in the context of selection, is because we need to know how to interpret these things. However, there are other ways to do that too. For example, we can parse the value, we can parse the string, and that's what we'll see soon is Java has parsing functions, and you could actually put the string true, and the word true would evaluate to the value true, and the word false would evaluate to false, and anything else, maybe that gives you an exception, throws an exception and says, I don't know what you want this to be. I don't know what dog is. I don't know if dog is true or false. The word true is true, the word false is false, and everything else is I don't know. Okay? But that's what we're talking about when we're coercing a value, is we have to, or the function that we're calling has to have implemented a set of rules for how to interpret what's in this data type to get the other data type that we're trying to get. So it's very interesting. But a lot of it is simply programmer conventions that have been written into the software over time. You know, it's common ways that we typically will coerce these values, and so somebody writes the code to implement it that way, and we just move on. Yeah. So another little interesting trivia, there's this class that somebody implemented called Boolean utils, and it has a method or a function called toBoolean. And I find this one pretty interesting. It says, look, I'm not going to tell you how to coerce the value. I'm going to say, you give me a value, and then you give me the value if it's true and the value if it's false. And notice this is talking about integers. So let's say we have an integer and we want to tell whether it's true or false. Maybe 1 is true and 0 is false. Well, what about -1? What about 417, right? We've got to decide. Okay, so maybe then we say positive numbers are true, negative numbers are false. Well, what about 0? We left 0 out. Is 0 true or false? So somebody has to come up with those rules, but somebody in the Java world wrote this function called toBoolean. You can say, look, there's only 2 possible allowed legal values, 0 and 1. So I'm going to call toBoolean with what the user entered, let's say, and a 0 and a 1, or a 1 and a 0, and that's how this function will interpret and coerce that value into a true or a false. So as Java programmers, we just have that function available to us. Somebody already implemented it. And then similarly, this is the function I was just talking about, parse Boolean. You can pass it the word true or the word false, and it will interpret it for you. The thing is, what if true was all capitals? Is that also going to be true? What if it's capital T RUE? Is that also true? Well, the way this parse Boolean is implemented, I don't think it works that way. So we can fix that really easily, though, using that function. So I can say, right, let's say I have this, and what is it, parse Boolean? Yeah. B equals. So is B going to be true or false? So is it going to print yes, or is it not going to print yes? Well, I don't know. But one thing that I can do is I can call another function to convert whatever that value is to lowercase, and then I don't have to worry about it. So now if I type true, or that, you know, whatever I do, whatever variation gets typed in, I'm converting it to lowercase, then I'm passing it to parse Boolean. So now any variation, as long as it has the word or the letter T, the letter R, the letter U, and the letter E, it's going to evaluate to true. So that's a way I can, as a programmer, get around that, and that's the reason why the people that write this parse Boolean can say, look, if it's lowercase true, it's true. If it's not lowercase true, it's false. So once again, you just have to Google it and figure out how that function works. But it doesn't matter because we've got options. We can adapt, we can overcome. Any questions about those Or have I completely confused and lost you at this point? Okay, the next variation of our selection list of patterns is what I call, well, what is called the compound if. And now it hopefully will make sense why we just stopped and talked about these Boolean operators, logical operators, because a compound if is one where the expression that we're testing involves multiple sub-expressions combined together with logical operators, and, or, and not. And the great thing is we don't have to learn a new thing to flowchart, because all we do is we put more junk inside the little diamond box. The expression just gets more complicated, but it's exactly the same kind of flowchart. And you'll hear a term about called short-circuiting. The Java compiler, other compilers can short-circuit the execution of all of these things. It's a really interesting concept from a computer science point of view and a language, like a compiler construction point of view. When can I stop evaluating these expressions? Like if the temperature passed into this little function here is 55. Okay, so the first clause of this compound if statement says if Fahrenheit is greater than 70. Well, 55 is not greater than 70, so that's false. So I have this and this and this. Do I even need to evaluate the other two portions of this? Because I already know the first one's false. False and whatever comes after it is all going to be false. So I could just stop right there, right? So anyway, that short circuiting is an interesting thing. I don't really go into it in this lecture, but it just popped into my head. Any questions about compound before I move on? It's really simple. It just has, it's the expression has and or not in it. Okay, next pattern is nested. And this one gets interesting because it gets more and more complicated the more combinations of things that you can do. And it's probably a good time to point out that I've been trying to keep the block of code that executes inside these statements to be pretty simple just for presentation purposes. But the things being executed in here can be very complicated. Lots and lots of other control structures. You could have a loop inside an if statement. You can have input-output calculations all inside an if statement. I'm just keeping it simple, hopefully, for the presentation. But this one does get a little bit more gnarly. And there's maybe some logical similarities between this and what we just talked about with the compound if. I'm able to still do some interesting things here with the temperature, but so I'm testing the same kind of data, but applying it to different algorithms to get the results that I want. But the main characteristic of the nested if statement is simply you have an if statement inside another if statement, inside the if side or the else side of another if statement. Clear as mud? Didn't lose anybody there? Okay. The next one gets even more interesting. It's what we would call a cascading, or you might hear a waterfall if, cascading if, cascading nested if is another term for it. And the kind of place where you would use something like this is usually where you have, in this case, I'm using the variable f, and I'm testing it for a different condition in each one of these nested structures, right? Depending on, this is maybe where the the phrase, oh, hey, how you doing? Oh, I'm fair to middling. Well, that would mean I'm somewhere between 70 and 80 degrees, right? Okay. Teacher humor, sorry. But this happens commonly enough in programming and the kind of problems that we have to solve as programmers that it gets its own pattern. We have a name for it. We say, oh, we need a cascading if statement here. That's the appropriate way to implement this, is with a cascading if statement. You know, you can flip it around. You could do the code to be executed on the no side of the ifs as well as the yes side of the ifs, you know, whatever the logic of your algorithm requires. But the characteristic here is that it's one if within another until you get down to the end. And then the end one, again, joins up. So we have that single point of entry, single point of exit. Then those join up and those join up and those join up. And this is one of those areas where I was talking about where sometimes programmers get lazy when they're flow charting it. And one of these lines can go off in some other direction. It's like, no, sorry, that does not represent what's happening in the code. This is how you, on the right side, this is how you would flow chart the code that you see on the left side. And if any of your arrows are going off the other direction and not joining up, then you're doing it wrong. It's like buttoning your buttons on your shirt not right. Just don't do it that way. Okay? The next one is the switch thing. So this is a special case of the previous one. You know, this one, you know, is close, but there's a distinction between when the cascading if is appropriate and the switch statement is appropriate. Notice these expressions. Is f greater than 90? Then do this. Else, if it's greater than 80, do this. Well, I know if it gets to this middling box, then the temperature is between 80 and 90. It's not greater than 90 because otherwise it would have gone here. So this is kind of like a form of a filter, you know, like a sieve. You're filtering the logic into the slot that you want it to go in based on the range of the value that you're testing. And that's where this cascading if is appropriate. But the switch is a little bit more specific. What you typically would do here is you have one expression like the F part of that previous expression, the temperature, and you're going to test that same expression against different specific values, not ranges, but specific values. So in this case, I'm doing the same thing, but all I did was I divided the temperature by 10, so now I get a 98765 instead of 90, 80, 70, 60. So I'm just being clever there a little bit so that I can illustrate the switch statement. So if it's a 9, we do this assignment. 8, we do this assignment. 7, we do this assignment. And it's important to remember that in Java, you need to put the break statement there. I think in Java, you'll get a compiler error if you forget to put the break, because they want you to explicitly know that if I do the first assignment, how good equals sweaty, it's not going to then fall into the next one and also do the assignment for Midland. That doesn't work that way. It does the assignment and hits a break, oops, and then when it hits the break, it jumps all the way out to the closed curly brace out here and then continues on. And I think like on the default down here, if it's not any of those values, then it goes into the default. Default is optional. You don't have to have a default clause. But I don't think you have to have this last break statement. I don't think you'll get a compile error there. I put it on there for completeness, but I don't think you have to have that. I think it's optional. And I mean, it may seem obvious, but like in C++, you don't have to have the break statement. You can actually write your code so that it executes this first assignment and then falls through to the next one and executes them all. You don't have to break. It's a little bit more, hey, do it at your own risk kind of a thing in that language. And then this is how you used to have to code that, and you notice how wow, it takes quite a few lines of code and you have to keep repeating this break statement over and over and over again, when it's like, well, yeah, duh, obviously it's gonna break. So they came up at some point, I don't remember what version of Java this came along, they gave us this nice new kind, they call it the enhanced syntax for the switch statement. It's still a switch statement, but if you code it this way, you don't have to put the break statements in there. You just use this little arrow and makes it look a little bit cleaner. It's doing the exact same thing, has the exact same requirements, same expectations. It's just a little bit cleaner syntax to do the same thing. Either way will work in Java. So it's personal preference, whichever one you want to use. And one of the reasons why they do things like that is backwards compatibility, because for many, many, many years, Java was only supported the method on the left. So you will see the pattern on the left. Even if you decide that, no, I far and away wanted to use the enhanced one, you're still going to go work someplace and they're going to have lots of code that looks like what's on the left. Okay? Any questions about how that works? Okay. In Java, we also get this cool thing called a ternary operator. Ternary just means that there's three operands. There's no other fancy connotations to that name. And the only reason why they can do that, I mean, we've got a whole bunch of unary operators in Java. We've got a whole bunch of binary operators that they don't mean you're dealing with zeros and ones. It means that they take two operands. Like x greater than or equal to y is a binary logical operator. It's a logical operator that takes two operands, an x and a y. Okay, it's a binary operator. It's one of many binary operators. But when we talk about the ternary operator, there is only one of those. So instead of coming up with some other fancy complicated name for the operator, they just call it the ternary operator because it's the only one. And it's like the enhanced switch statement. All it does is gives us maybe a little bit cleaner, more compact way of doing the same thing. So these two examples do the exact same thing. The one on the left says if value is greater than 5, do one print statement, else do the other print statement. The one on the example on the right says evaluate value greater than 5, and if it's true, return the string value is greater than 5. If it's not true, return value is less than or equal to 5. And that lets us basically do what took me 1, 2, 3, 4, 5 lines of code on the left. I could do, if I didn't do the line breaks, I could do all that in one line of code on the right. So it makes it much more compact. 5 down to 1 is pretty good savings. Okay, everybody got that one? All right, we made it. We got through selection. And so